This video, the last in the three-dimensional figures unit, is all about applying your newfound knowledge to solve problems involving real-world applications. All right, in this video, we're only going to look at one example, so let's go ahead and get started. It says that trees that are cut down and stripped of their branches for timber are approximately cylindrical in shape. This timber company specializes in a particular type of tree with a diameter of about 50 centimeters and a typical height of about 10 meters. The density of wood is about 380 kilograms per cubic meter, and we can sell the wood at a rate of $4.75 for every kilogram. They want us to determine and state the minimum number of whole trees necessary in order to raise at least $50,000. Now, this problem has a lot of parts to it, and the key to doing this successfully is doing one part at a time and remembering to label units and what variables represent at every stage in the whole problem-solving process. So I'm going to go ahead and reread the question and maybe circle, underline, highlight key facts that might be helpful in solving the problem. The first thing that they tell us is that these trees are cylindrical in their nature. Now it tells us that this particular tree has a diameter of 50 centimeters, and I know that in finding volume, diameter isn't very helpful, so I might just make a note to myself here that the radius is actually 25 centimeters. The height is 10 meters. Notice that one of these dimensions is given to us in centimeters and the other in meters. So we're going to have to do some conversions here between units of measure. The density of the wood is given to us to be kilograms per cubic meter. So that right there tells me that I probably want to do all my computations in meters. And we can sell this for $4.75 for every kilogram of wood that we have. Okay, that's good because this density was given to us in kilograms, and again, they're asking us to work in kilograms, so we're not going to need to convert. We're looking for the minimum number of whole trees that we need to sell to earn at least $50,000. Okay, so I'm going to go ahead and start with a picture of what these trees might look like. So cylindrical in shape. We know the radius is 25 centimeters. And that the height is about 10 meters. And again, I'm noting this mismatch in dimensions, meters and centimeters. Because the density that they're giving us to work with is in kilograms per cubic meter, instead of working in centimeters, I'm going to want to work in meters. So that 25 centimeter radius has now become 25 1/100ths of a meter radius. Because I'm working with density, it might be helpful to put the formula down on my paper. And then I'm going to go substitute some facts or some values into that formula. So the density is 380 kilograms per every 1 cubic meter. I want to find the mass that's necessary, and I can find the volume of this cylinder. From the formula sheet, volume is pi times r squared times h. So I'm going to enter this into my calculator. You should, of course, be entering it into your calculator at home as you're viewing the video. Also, both to double check my mistakes, double check my work for mistakes, and to make sure that you know how to enter this on your own. So 625 times pi, and again, I'm going to leave all my calculations in terms of pi because it's the most accurate and precise unit of measure. So my volume here, 625 times pi meters cubed. Since my density is given in kilograms per cubic meter, and I've got cubic meter over here, I know that when I find the mass will be in kilograms. So I'm going to go ahead and cross multiply in order to find the mass. So the mass here is going to be 380 times 625 times pi. I guess that's 0.625, so I need to go back and make that correction. This should be 0.625. This should be 0.625. So I can either go up and grab that and drag it down or just retype it in. And I want to cross multiply that times the 380. And again, I'm not going to multiply through by the pi. I want to leave the pi in my calculations because it's the most accurate and precise way to calculate. So I find that the mass is 237.50 times pi, and we're in kilograms. So that, recall, is for one tree. Now I know that for every kilogram we have, we're going to earn $4.75. So I'm going to go ahead and multiply that times $4.75 in order to determine the value of one tree. And again, I'm going to leave it in terms of pi because it's the most accurate and most precise. So the value of one tree is 1,128.125 pi. And I want to raise here at least $50,000. Well, if I wanted to raise $50,000 and I know the value of each tree was $10,000, I would just divide. So I'm going to do exactly the same process here. I'm going to take the $50,000 that I'm trying to earn, divide it by the value of each tree, and that'll tell me exactly how many trees I need to have in order to obtain that $50,000. So again, I'm going to go substitute that right into my calculator exactly the way I see it, using the fraction bar, not using the divided by symbol. Remember, you should be entering this into your calculator at home as we go along to make sure that I'm not making any mistakes in the calculations and to make sure that you know how to enter it in the calculator when your turn comes. So I find that that's about 14.11 trees. So now the question is, I need to know, I can't cut 14.11 trees. I either need to cut down 14 trees or I need to cut down 15 trees. If I cut 14 trees down, I'm just going to be shy. I'm not quite going to make that $50,000 mark. So I know now that in order to get to, or to get greater than or equal to the $50,000, I'm going to need to cut down 15 trees. So obviously there's a lot to remember as you work through these types of problems. Again, I'm going to have you, like always, think about, summarize the key ideas and the important takeaways that you're going to need to recall from this video, and then see if you can apply your newfound knowledge to solve the contracting problem on the next page.